Current in intrinsic semiconductors. The way a material conducts electrical current is important in understanding how electronic devices operate. You can't really understand the operation of a device such as diode or transistor without knowing something about current in semiconductors. An intrinsic or pure semiconductor has two types of charge carriers. First is electrons that are negatively charged, and second is holes that are positively charged. At room temperature, pure semiconductor has sufficient heat or thermal energy for some valence electrons to jump the gap from the valence band into the conduction band, becoming free electrons. These free electrons are also called conduction electrons. Now, look at this figure. When an electron jumps from the valence band to the conduction band, a vacancy is left in the valence band at the electron position within the crystal. This vacancy is called a hole. For every electron raised to the conduction band by external energy, there is one hole left in the valence band. Both the free electrons in the conduction band and holes in the valence band are generated at the same time. These free electrons carry the negative charge or electric current from one place to another in the conduction band, whereas these holes or vacancies, they carry the positive charge or electric current from one place to another in the valence band. In intrinsic semiconductors, the total number of negative charge carriers or free electrons is equal to the total number of positive charge carriers or holes or vacancy. This is called an electron-hole pair, as you can see here. Now, what is recombination? Recombination occurs when a conduction band free electron loses its energy and falls back into a hole in the valence band. This figure illustrates electron-hole pairs in a silicon crystal. As you can see here, free electrons are being generated continuously, while some of these free electrons recombine with holes, as you can see here. So this is what we call generation, and this is recombination of carriers. Now we will understand electron and hole current. There are two types of current produced in a pure or intrinsic semiconductor. First is electron current and second is hole current. When the voltage is applied to a pure or intrinsic semiconductor, the free electrons move towards the positive terminal of a battery and holes move towards the negative terminal of a battery. We know that electrons are the negatively charged particles and holes are the positively charged particles. Since like charges repel each other and unlike charges attract each other, therefore the electrons or negatively charged particles are attracted towards the positive terminal of a battery and holes or positively charged particles are attracted towards the negative terminal of a battery. This movement of free electrons in the conduction band is one type of current in a semiconductive material, and it is called electron current. Another type of current occurs in the valence band where the holes created by the free electrons exist. It is called hole current, in which the hole has moved from one place to another in the crystal structure. Although current in the valence band is produced by valence electrons, it is called hole current to distinguish it from electron current in the conduction band. Now, look at this figure. It illustrates generation of electron current in intrinsic silicon. This electron current is produced by the movement of thermally generated free electrons. As you can see, these free electrons, being negatively charged particles, are attracted towards the positive terminal of a battery. Now, look at this figure. This figure illustrates mechanism of hole current generation. Look at these steps. In first step, a free electron leaves a hole in the valence shell. In second step, a valence electron moves into this first hole and leaves a second hole behind. In third step, a valence electron moves into this second hole and leaves behind a third hole. It means when a valence electron moves from left to right to fill a hole, it leaves another hole behind. On the other hand, the hole has effectively moved from right to left. These gray arrows indicate effective movement of a hole. So, it means electrons are moving from left to right and holes are moving from right to left. This is how hole current is generated in intrinsic silicon.